Dear students, now we see the topic electrochemistry session 9. Before watching this video, you subscribe this channel and press the bell button and click the link in description. Okay, thank you. Now in this session the learning objectives are secondary batteries. Secondary batteries means last session we saw the primary batteries. Now lead storage battery and then lithium ion battery and fuel cell. This is the topic. We will see the topic one by one. Okay. Next. Now this is the secondary batteries. Secondary batteries already know that primary two types of classification. One is primary and second is secondary. Primary means non-rechargeable batteries. Secondary means rechargeable batteries. Now the detail. We have already learned that the electrochemical reaction in electrochemical reactions takes place in a galvanic cell may be reversed by applying the potential slightly greater than the EMF generated by the cell. In this battery, only the reversible galvanic cell circuit slightly greater than the EMF generated by the cell. Okay, this is the basic principle. This principle is used in secondary batteries to regenerate the original reactants. Original reactants means two-way process. One is charging, another one is discharging. These are the two processes there in secondary batteries, charging and discharging. Okay, therefore the function of secondary cell, considering the lead storage battery is an example. Lead storage battery means we used in inverters and then car batteries and bus batteries, lorries, they used are lead storage battery. Okay, this is the lead storage batteries. The image is there. Now the principle is description is that is specification is anode spongy lead. Spongy lead means softness, very soft lead, spongy lead. And then cathode lead plate bearing lead oxide. Electrolyte is very important. 38% by mass of sulfuric acid with density 1.2 gram per milliliter. Okay, 38% of sulfuric acid. Normal density is 1.2 gram per ml. Okay, this is important for the lead storage battery. Now see the diagram. Image is the cell inside components are there. The two components, positive and negative. Here negative plates lead grills with a spongy lead. This is the negative. Already seen that galvanic cell cathode, but here the reverse is anode. Anode is a spongy lead, and then act as a anode. Cathode is act as a anode. Next, positive plates, lead grills filled with lead oxide. Here this is a cathode, act as a cathode. Sulfuric acid and water is electrolyte. The two components are separated by the plate. Opening with add water is we know that in the cell the lot of open holes are there, positive and negative electrodes are there. This is the structure. Okay. Now the basic principle of the through chemical reaction, oxidation occurs at the anode. Lead is losses of electron. Lead is converted to anode. In anode, lead is converted to lead 2 plus ion and 2 electron, loss 2 electron. The 2 plus ion combined with SO4 minus 2 ion. This is from sulfuric acid. This is from sulfuric acid. This ions from sulfuric acid, sulfate ion. The Pb2 plus combined with SO4 2 minus combined with forming lead sulfate. The precipitate is formed. 2 plus SO4 2 minus gives lead sulfate. The reduction occurs in cathode. Reduction occurs in cathode means lead oxide plus H plus from acid. Here sulfate ion, here H plus ion and then losing electron, 2 electron. These 2 electron accepted by lead oxide to converted to lead 2 plus ion and then H2O. The 2 electrodes common ions are lead 2 plus ion. Here also 2 plus ion, here also 2 plus ion is there. So the common ions are lead 2 plus ion. Lead is converted to lead 2 plus ion, lead oxide converted to lead 2 plus ion. Okay, this is the principle. The lead 2 plus ion, total sulfate ion combined with sulfate ion form lead sulfate. This is the precipitate. Okay, lead sulfate, lead ion and then sulfate ion forming lead sulfate. Okay. Overall reaction 1, 2, 3, 4. 4 reactions are added. Lead plus lead oxide plus H plus and sulfate ion. These two are in from sulfuric acid, H plus ion and sulfate ion. Lead is there from electrode, lead oxide from electrode. So totally 4 reactants are there forming lead sulfate and water. These are the overall reaction from 1, 2, 3, 4. Okay. Now the EM of the single cell is about 2 volt. Underline it. This is a very important 1 mark question in NEET exam also. EM of the single cell is 2 volt. 2 volt means one battery is EM of a single cell is 2 volt. The such 6 cells are combined with form 12 volt combination. Okay, chamber by chamber they connected with each other. Okay, 6 such cells are combined in series to produce 12 volt. Next, EMF of the cell depends on the concentration of the sulfuric acid. Very important very important concept in this cell. The EMF, only the EMF depends upon the sulfuric acid because already you know that lead is combined with the sulfate ion gives lead sulfate. As the cell reaction uses sulfate ions, the concentration sulfuric acid decreases. This is the discharging time. Discharging time, the reverse reaction is formed. Sulfuric acid is decreased. Lot of days we use the battery, the reverse reaction occurs. Therefore, sulfuric acid is decreasing. When the cell potential falls about 1.8 volt, that is 12 volt from 2 volt from 1.8 volt, it has to be recharged. We will do the recharging process. Okay, this is the inverter plan in home and then factories. This is the principle. Because the battery's life is depends upon the sulfuric acid. They discharge H plus and SO4 2 minus ion. Next, recharging the cell. This is charging, this is recharging. In earlier, the potential greater than 2 volt is applied across the electrodes. The 2 volt normally EMF of the single cell is 2 volt. Greater than of 2 volt is applied to electrodes. The cell reaction takes place during the discharge process is reversed. Discharge process are reversed. Reversing processes occurs. During the recharge process, the role of anode and cathode is reversed and sulfuric acid is generated. Already I saw the here the cell reaction uses sulfate ions, the concentration sulfuric acid decreases. The recharge process also, the role of an anode cathode is reversed. Reversed means anode to cathode, change anode to cathode, cathode to anode, reversing, and sulfuric acid is generated. Sulfuric acid again generated. Okay. Next, during the recharging, the anode is cathode is act as a anode act as a cathode. This is the recharging time. Lead sulfate is combined with water gives lead oxide. You know very well, lead oxide is one of the electrode. So lead sulfate is reacting with H2O. Again lead oxide is we require the lead oxide at the time of recharging. Okay. Lead sulfate already using time, the lead sulfate is formed. This lead sulfate with react with water, lead oxide is formed, and 4H plus ion that is dissociation takes place, H plus and SO4 2 minus. Sulfuric acid is splitting positive and negative ion and losses of 2 electron. This is in cathode. The reversible process anode act as an anode at the time of recharge. Next, cathode in cathode, that is anode. At the anode, the charging and recharging is reversed. So this is the condition. Lead sulfate plus 2 electron combined with electron. Already lead sulfate ion is a lot of lead sulfate ion is there. Again lead sulfate ion, the releasing electron is accepted by them and then formed lead and sulfate ion. Again lead and sulfate is reused at the time of charging. This is recharging process. So overall reaction, lead sulfate and H2O gives lead oxide and H plus and SO4 minus. Totally lead sulfate is combined with water. The 4 types of ions, the splitting, lead oxide, H plus ion and sulfate ion. These are the principle of charging and recharging. Before that charging, this is recharging. Okay, this is the 2 methods for cells, discharging one, charging one. Discharging means positive act as a anode and negative act as a cathode. Charging is positive act as a cathode and minus electrode acting as a anode. This is the reversible processes. Lead oxide accept 2 electron. Lead oxide accept 2 electron. They form lead 2 plus ion and then lead sulfate ion. Lead sulfate is formed because of from electrolyte. The electrolyte is H plus ion and SO4 ion. Here also lead is formed. Already electrode is there, lead. lead loss of electron, and then again lead sulfate is formed. Totally the two electrodes have the lead sulfate ion. Here electrolyte sulfuric acid. Sulfuric acid is split into H plus ion and sulfate ion. These sulfate ions combined with the lead 2 plus ion formed lead sulfate. Here charging is lead sulfate is disposed to SO4 2 minus ion and 2 plus ion. Then oxide is formed in cathode. In anode, lead sulfate is split into lead 2 plus loss of splitting Pb 2 plus and SO4 minus. Again it accepts two electrons to form PbO2. Here this is the recharging. Okay, the second cell is recharging, first cell is discharging using batteries. This is the principle. Cathode PbO2, anode Pb, electrolyte sulfuric acid. You already know the specification in introduction. Okay, this is the cell. The overall cell reaction is exactly the reverse of the redox reaction takes place while discharging. Already explained that charging one occurs, recharging reverse process occurs. These are the principles. Uses used in automobiles, trains, inverters. You know very well. These are the applications of the various fields. Inverters in medical field also, data center also, vehicles also, UPS system, inverter is used, and then telecommunication and security systems. So many uses are there in the charging and recharging process. Next, lithium batteries. Lithium batteries are familiar with us in nowadays because we used regularly in mobile phones. Mobile phones have the lithium-ion batteries. Lithium-ion basic principle of lithium-ion batteries are this is the big one. Okay. Here there is a mobile phones. Lithium-ion. This is the power bank batteries. Next, mobiles. Next, vehicles. Okay, lithium-ion batteries. These are also the okay. The principle. The basic principles are, that is specifications are: anode porous graphite. Porous graphite means the small holes are there. That is porous graphite. Cathode is a cobalt oxide. Transition metal oxide such as cobalt oxide. Cobalt oxide is a acting as cathode. Anode is porous graphite, and then cathode is a cobalt oxide. Electrolyte, lithium salt in organic solvent. Lithium salt in an organic solvent. Okay. Here at anode and cathode reactions are there. Lithium metal split into lithium plus ion, positive ion, and electron, one electron released. Okay. Next, this two ions, lithium and electron ions, are combined with cobalt oxide in cathode. The reduction occurs, changes to lithium cobalt oxide. Lithium cobalt oxide solid is formed. Okay, in cathode the reduction occurs. This is oxidation, this is reduction. Okay, overall reactions, lithium metal and cobalt oxide gives lithium cobalt oxide. Overall reactions in lithium ion battery, discharging and charging and discharging also occurs simultaneously. This reaction forward and backward occurs. Okay, this is the whole reaction in this cell. Both electrodes allow lithium ions to move in and out their structures. The lithium ions are at the time of charging, they go to inside the negative electrode between the layer they placed. This is the charging time. So discharging time means using regularly. That time the lithium ion releases from the electrodes, negative electrodes, and come to the compound side. This is the movement of lithium ion atom. So this is the lithium ion, basic concept of lithium ion battery. Okay, lithium ion combined with one electron and cobalt oxide gives lithium cobalt oxide. This is the basic principle. At that time the electrical energy is produced. Okay, during the discharge, the lithium ions produced at the anode move towards cathode, anode to cathode. This is the discharging time, moving to the cathode. This is the anode and this is the cathode. The anode, from anode, the lithium ion releasing to cathode. Combined with cobalt oxide give lithium cobalt oxide. Okay. Next, when potential greater than the EMF produced by the cell applied across the electrode, this is the condition. The EMF, potential greater than the EMF produced by the cell is applied across the electrode, the cell reaction reversed. The cell reaction is reversed, just reversed. Charging and recharging takes place this method. Okay. Lithium ions move from cathode to anode, lithium ion cathode to anode. This is the arrow mark, from positive to negative. Positive is cathode and negative is anode. Okay, embedded on the porous graphite electrode. Embedded, I already told that they placed in between the two layers of the graphite. Okay, this is the principle. The lithium ion battery is used in cellular phones, laptops, computers, digital cameras, etc. This is a lot of applications. Mining means that is industries, mining industries, and space applications. Consumer electronics, we have used mobiles and laptops and then computers. These are the electrical vehicles also. Now we are fast moving electronic goods. Okay, next, defense ministry applications, railways, current railways, and then solar energy storage, and then telecom towers, the signal towers, and then marine applications, energy storage system, and then power inverters. These are the lot of applications in lithium ion batteries. Okay. Now fuel cell, the galvanic cell in which the energy combustion of the fuels is directly converted into electrical energy is called the fuel cell. What is fuel cell definition? Very important. The fuels are burning and converted into electrical energy. This is the definition for fuel cell. Fuels are burned. What type of fuel? We will see that. It requires continuous supply of reactant to keep functioning. Continuous supply. Termination. Without termination, this fuel cell is working. Okay. It requires continuous supply of reactant functioning. Okay, a general representation of the fuel cell is follows. The diagram is there. The cell notation is fuel, electrode, electrolyte, electrode, oxidant. This is anode and this is cathode, or this is cathode, this is anode. Two-way process. That's why the fuel and electrode, positive electrode, that negative electrode and oxidant, fuel one type and oxidant one type, electrolyte general electrolyte. Okay. Now let us understand the hydrogen oxygen fuel cell. Hydrogen is the in this case hydrogen oxygen fuel case, hydrogen is the fuel and oxidant is the oxygen. Okay. Electrolyte is the aqueous potassium hydroxide solution maintained at 200 degrees C and 20 to 40 atmospheric pressure. Okay. This is the 1 mark question. Now porous graphite electrode containing nickel and nickel oxide serves as the inert electrodes. The porous graphite electrode containing nickel and nickel oxide. The graphite containing graphite porous means you know very well, small holes is there, that is like a sponge, that is porous graphite electrode containing nickel and nickel oxide. Okay. Now diagram is there. This is the diagram for that. Inside hydrogen, this is the fuel, hydrogen allowed to inside the cell. This is the way, hydrogen way. Next oxygen, another side oxygen is the inside the go to inside. Cathode is there, here anode is there. Okay. Anode is a graphite and then cathode also graphite, but nickel and nickel oxide. This is the process. Okay. Next center part, the membrane is there. Membrane, two side membrane. The catalyst layer is there. Okay. This is the process of electrode. Center, this is the porous gas diffusion layer. Because we allow to oxygen and hydrogen smoothly inside the membrane. That's why the porous gas diffusion layer is there. This is very important. Next, catalyst layer, membrane both sides are catalyst layer. Now anode, hydrogen loses the electron, 2 electron. Hydrogen is lost 2 electron. H2 is 2 hydrogen plus ion and 2 electron, releases 2 electron. This 2 electron is combined with oxygen, also hydrogen and oxygen and electron combined with each other gives water. Water is collected outside. This is the way to vent out the water. Okay. This is the process. Whole process is there. Okay. Hydrogen inside and oxygen another side. They allowed inside the cell through anode and cathode. The porous diffusion layer is there. They went inside through the porous cell and through membrane. They react with each other. They give the water, but energy is released. Total of energy is released. This energy is converted to electrical energy. This is the process. Oxidation occurs at the anode. Means hydrogen gas inside. We allow the hydrogen gas inside, and then hydroxide ion from electrolyte. Hydroxide ion is water, from water. Hydrogen gas is allowed and hydroxide ion is from water. They combined with each other, water is formed and losses 4 electron. 2 hydrogen losses 4 electron. 1 hydrogen losses 2 electron. Next, cathode. Oxygen is another side is cathode. Oxygen is allowed as an oxidant. The oxidant is combined with water and 4 electron gives 4 hydroxide ion. The overall reaction is both two reactions, adding two reactions, hydrogen and oxygen gives water molecule. Now the above reaction same as the hydrogen combustion reaction. Hydrogen combustion means burning hydrogen. Burning hydrogen is the reaction. Okay, do not react directly. Do not react directly. The hydrogen do not direct not burning. But oxidation and reaction takes place separately at anode and at cathode. Oxidation, reduction, same at a time. Redox reaction is taking place, and then hydrogen oxygen fuel cell. The fuel cell propane, modern technology, propane oxygen and methane oxygen also is developed. Okay. Now next session we see the topic electrochemical series, corrosion, and then electrochemical mechanism of corrosion. These are the topics of next session. Okay. Thank you for watching this video. Please subscribe my channel and click the bell button for notifications. Click the link also. You click the link also in the description box. Thank you.